Hey, I'm just gonna walk you through homework 5, and it is a very long homework and hard one to explain, so just bear with me, and let's get started. So the first thing you need to know is the difference between core space and disk memory. So core space are any address that span from 000 inside of Vesp all the way to FFF, yeah, 3 Fs. While disk memory is any address that spans from 1000 all the way to FFFF inside of Vesp. And the difference between the two is that any program that you wrote inside of disk or the disk memory will not run. Code will only run inside of your core space, anywhere inside of your core space. So if you have a program that is written inside of the disk memory, you have to first transfer it over to the core space in order to run it. And that is a very important concept you need to know and remember. So the reason for that is, if you notice, core space only uses up 3 digits of memory. Well, that's kind of wrong, but core space only uses up 3 digits for its memory space. So FFF is the last base for the core space. And this digit was not used by the core space at all. The reason for that is this last digit over here is reserved for the opcode. Meanwhile, this memory uses up all 4 digits for its memory space. And as you know, 1 digit of hex is like 4 bits in, just 4 bits. So this memory have 2 to the 4 times extra space than core space does. So in general, this memory just have more storage space than core space. That's why if there's any program that you're not going to use, you just store it in here. And if you're going to use them, you're going to transfer it over to core space and run it. Yeah, so the key point I want you to know is code does not run here, but code does run here in the core space. That's all you need to know. And yeah, so let's look at the code. I'm not exactly sure how they want us to do the homework, but I would assume that it will look something like this. I'm just going to run it so you see what you're supposed to do. So first, when you load up Vesp, it's going to ask you to enter in a key. So you enter in Q for the program they asked you for. Then it's going to ask for a starting address. And they want the starting address of a space in the disk. So let's say I want to start at address 1120. So I type in 1120. Then they ask for a key to search for. Let's say I want to know where the value 2489 is located. So I type in 2489, and it's going to return me the address where it resides, which is 1162 right there, right? So it's correct. Again, Q, give it a starting address, and it's going to search within 256 or 255 blocks of data. So I'm going to try to search for FO18. FO18, it has to be capitalized, and there it returns 112F, 112F, 112F. Oh yeah, there's another FO18 over here, that's why. So it returns to me the first address that it found the value FO18 in, which is 112F. And one more time, 1120 as the starting address. And I'm going to search for the value 6969, and it's going to return not found because it doesn't exist here. So I think that's what they want you to do for the program. So for the example I'm going to do in this video, I'm going to do something different. The example I'm going to do is, it's going to ask you to enter in a key. So my program will have the letter A as the hotkey or whatever. And it's going to ask for an A value and a B value. If a minus b is equal to 0, it's going to return to me or output display on the screen the word 0. And again, if a minus b is not equal to 0, then it's just going to store 999 into a and display that. So it's going to display 9999, which is in address A right now. I mean address 000, the A register. And that is what I'm going to show you how to do in this example. But concept is the same. You got to put some kind of code inside of your Vesp code and run it. So let's get started. So first thing you want to do is open Vesp 3.2xk. Scroll all the way down. And copy, starting from case L, all the way to the spot where it says RAM address. Just copy that. Scroll all the way down to the very end of the switch statement. And yeah, my code is going to start here. Alt tab, there you go. Oh, I did this before. My bad. So, yep, here's the end of the switch statement. I'm just going to copy and paste it in here. And don't forget the break command at the very end. Alright, yeah, there should be a break command at the end. So the first thing that you will see is case L. Well, in my example, I want to type in A to run my program, so I'm just going to switch this to A instead. And here should be the starting address of where your code will run. So remember how previously this was the code for load? Let's open a clone of the view. So actually, let me explain this real quick. So this is your disk space. This is the space that's down here. So these are just like data stored inside your program. So at the start of Vesp, like at this line of code right here, Vesp is gonna boot up and it's gonna transfer all of these code into your core space up here. So that's done automatically. The code for that is already written. You don't have to worry about it. And this line right here, it's just saying change your pointer counter to address 781. And like when the program booted up, it's going to transfer this code to address 800. No, there you go, 781. So this line of code is going to run at the when you type in L, right? Because pointer counter is going to point to address 781. And that is where this code is located. Like, ignore this HDISK over here. HDISK is separate from the address of the core space over here. And you got to keep track of these numbers over here. So make sure you don't like fall off or lose track of them. So the first thing I want to do in my program is to display this A colon over here. So to do that, let me delete that. I'm just going to scroll down, pick a space I want to write my code in, and copy and paste one of these code down here. So previously, my previous disk value or disk address was 1088. My next one should be 1089. And where do I want to display my A colon? So here's line 0 of the screen, line 2, line 3, line 4. Wait, 0, 1, 2, 3, 0, 1, 2, 3. Oh yeah, this is line 4 of my screen. And if you look in my cheat sheet, line 4 will start at address 400. So line 4 of my screen start at address 400. So I want to store my value in address 400. So load into address 400. The ASCII value for A, and the ASCII value for A is 41 in hex. So 0x 00 4A, no, 41. So this is just going to write down A. And this value will be stored inside of address 789. Because previously the previous code was stored in address 78A8, so the next one should be stored in 7A9. So yeah, just keep track of them. And this one will be stored in 7AA. Okay. So I got my A, now I need to display the colon sign. A, B, A, C. So load into address 401 the value for my colon, the ASCII value for my colon, which is 3A. And again, keep track of where it's transferred in the core space. Save this. So you have your code to display your A value in here. So the thing you want to do is change your pointer counter value to point to this address, so that your code would run. And this address is 7A9, so I'm just copy and paste that. Okay. So, excuse me. So when I type in A, the first thing it's going to do is go to address 7A9 over here, which is going to run this code, 2400. And then this one, and then this one, and then this one. But, you know, it's not going to do that automatically. That's why there's this function over here that actually runs the code. And ignore all of this, like ignore this for loop. I think it's really misleading and could confuse you even more. But the reason why he wrote this is because from the start, like when this line of code just run all the way till it gets your user input, it takes about 12,214 instructions to get from here to here. And you don't need to know that for the homework, so I'm just going to delete this line of code. Like the thing you want is this main cycle function over here. So what this does is every time this function execute, it's going to run one line of instruction from your code. So right here I have two lines of instruction. So I have load into 400, the value 41, that's the first line of instruction, and load into line 401, the value 3A, which is my second instruction. So I would want my main cycle to run twice. So this is going to run the first instruction, this is going to run the second instruction. So let's test it out real quick. And bear with me, this is going to be a long video. So I type in A, and there you go, it displayed A. So it works. And I don't want to copy and paste like main cycle all the time, so that's why I'm going to put a for loop to do it for me. So I just copy and paste it in here. So I is equal to 0, I is less than 2, because I want my main cycle function to run twice. Then I++. And this Vesp reset equals 0 here is just like a safety check. Okay. Then update screen. And this is how the function will work. It will update the y-axis on line 4 which is what we've written because we stored our value in line 4. Over here, we stored our value in line 4. And it's gonna write out or just change the screen in the X direction 10 units. So if you look here, it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's gonna stop somewhere here, 10 units out in the X direction. So if I change this to like, let's say 4, then it's just gonna display my thing 4 direction and the X direction. Okay. Yeah. So the next thing you want to do is display this thing right here, which is B:. So again, do the same thing. Keep track of where you're at. This is 7AC, so this should be 7AD, 7ADE, 7AF, 7B0. Yeah. And A9, AD, AE, AF, B0. I want this to display on line 5. So again, look at the chart. Line 5 start at address 440. So load into address 440 the value, the ASCII value for B, which is 42 hexadecimal. And the colon should have the same ASCII value, so I don't have to worry about it. Semicolon, yeah. So let's run it real quick. Whoops. That's not supposed to happen. See, the thing I forgot to do was update the address of where it starts. So over here, I want to go to the code where it displays B, which starts at address 7AD. So I'm just gonna change that to 7AD. Copy that. And rerun the code. See, there you go. And I forgot to change where it updates the screen. There's like 10 units out in the X direction. Let's make it 4, so the cursor will be closer to this thing over here. And another thing you might notice is that it didn't display the colon. That's because my main cycle didn't run the correct amount of time. So gotta update that. So here, to display B, it requires 2 instruction. So this is the first instruction, here's the second instruction. So it runs twice. So let's run that again. There you go. But it's still missing the colon. Why is that? Oh yeah. Over here, I didn't update it correctly. So instead of 4001, it should be 4441, right? So 440, the next line should be 441. Test that again. There's like a lot of debugging in this homework. There you go. And in the actual homework, it's not going to be A and B, it's going to be the address and key. So you got to figure out a way to write those. Anyway, these code will stay the same. This just to get your key input. And this code, you do not need to change at all. This part just converts your input right here, 1, 2, 3, 4, into ASCII characters. And then it's going to store your first input into address 10 of your Vesp, which is up here. It's going to store your input here. And this line of code will store your B value, or your second input, into address 14. Okay, so now I know that my first input value is stored in address 10, and my second input value is stored in address 14. I could start writing my code to actually do the subtraction stuff. So what I would want to do is write a pseudocode first, then convert that pseudocode into Vesp code, then input it into my disk, then I could run it. So here's the code I want to run. I want to do A minus B. And if A minus B, what was it? I forgot. If A minus B was equal to 0, it will print out the word 0. Otherwise, it will print out my A value. Or no, it should be otherwise. It will set A is equal to 999, then print out that value. So this is what I'm going to do for my Vesp code for my program. So the pseudocode for that will be something like A is equal to mem of OX10, because that's where my first input was stored. And B is equal to mem of OX014, because that's where my second input was stored. Then I would do A is equal to A minus B. If A is equal to 0, I would want to jump to wherever my halt command's at. Else, it's just going to continue on to the next line of code and set A is equal to 0, 9999. And my halt is somewhere down here. Now, one thing you want to be careful is you do not use the halt command. You actually use the no op command. So halt actually has a opcode of 7770, while no op has a opcode of somewhere down here, 77. And the difference between the two I noticed was that halt actually shuts down your whole program, while no op is like an end of file flag. It just tells the computer when your program ended. So this is what we're going to use instead of halt. But I'm just going to write halt because I'm just so used to it. So I'm just going to write halt instead. But just know this is supposed to be no op. So now that I have my pseudocode, I'm going to write my Vesp code for it. So the first thing you want to do is pick an address of where you want to start writing your program. That is the most important thing. I'm just going to pick somewhere down here. Oh, excuse me. Okay, so previously it's going to be a 11AD. I want to start at 11B0, which means that my code will be transferred to OX08B0, I believe, because the difference between this address and this address should be the same difference between this address and this address. Anyway, yeah, I'm just going to start my program here. So my starting address is 08B0. 08B0 is 2224. 2224. Okay, I'm going to start writing my code now. So, where's my pseudocode? The first thing I want to do is load into a register the value from memory 010. So I'm going to move into the A register. So I'm going to move into my A register the value from address 10, because that's where my first input is stored. Then I'm going to move into my B register the value from address 14. Then I'm going to do A is equal to A minus B, which is 3, opcode of 3. So 3000. No. That's not right. It's 03, my bad. So 0300. So this right here is A is equal to mem of 10. This right here is B is equal to mem of OX14. This right here is just doing A is equal to A minus B. And my if statement should be if A is equal to 0, I'm going to jump to halt, which I don't know the address of. And here, otherwise, you're just going to set my A is equal to 999. So load into the A register the value 9999. And no op. Remember, it's not halt. We're going to use no op instead. Okay. Which is like halt. Okay, so now we have our Vesp code. We're just gonna input it into our machine. So set it up. So we got 1 instruction, 2 instruction, 3, 4, 5, 6 instruction. So my first instruction takes 2 lines of code because it is a move command. Then my next one also takes 2 lines of code. Then my next one only takes 1 line of code. Then my next one also takes 1 line of code. Then my next one takes 2 lines of code. Then my last one takes 1 line of code. And also make sure these are all in sequential order. Wait, 0, 1, 2, 3, 4, 5, 6, 7, 8, and input in your code. So load, don't forget the OX, load into the A register, the value OX10. I'm just copying from here to here. That's all I'm doing right now. Oh yeah, jump to halt. Halt is at address 8B8. Yeah, so I'm going to change this to 8B8. Let's color code that. And I'm not going to keep track of this one because I don't have any more code to write. So this is my last line of code. So this one right here is saying A is equal to mem of 10 this B is equal to mem of OX14. This is saying A is equal to A minus B if A is equal to 0, jump to halt, or in this case it's no op. This is just setting A is equal to 999. This is just stopping the program, no op. Okay, so this is my program. And my programs start at address 08B0 when it's transferred over to my core space. So down here, I'm going to set the PC pointer counter to where my program started, which I already forgot. It started at address 8B0. Okay. And here's the part where you're going to mess up the most. Make sure your clock cycle matches up with your code. So first thing I want to do is do these 3 lines of code. So A is equal to mem of 10, B is equal to mem of 14, and A is equal to A minus B. So that will run 3 instructions, because 1, 2, 3. Then if A is equal to A minus B, if A is equal to 0, you're going to jump to halt. So this will take 2 lines of code. So if A is equal to that, jump here. That's 2 lines of code. 1, 2. So I'm going to do that if vesp.memory of the A register is equal to 0. I'm going to run these 2 code. So yeah, run it 2 times. Otherwise, if it's not equal to 0, then I'm just going to run this, this, and this. And it's like I'm just going to continue on to the next 3 lines of code which is 1 instruction, 2 instruction, 3 instruction. So else, it will run it 3 times, and the program ends. Let's save it and make sure it works for now. Like, always test your code before you make a big error. So G++ Vesp A 1, 2, 3, 4. Okay, so no error so far. So right here I'm just gonna cheat a little bit. So it's just gonna be testing if A is equal to 0. Then I'm gonna print out 0. Then go to a new line of code. If A is not equal to 0, then what was it? It's just gonna print out the value at address A. So if A is equal to 0, it's going to print out 0. If not, it's just going to print out the value at address A, which should be 9999. So let's run that again. A. Okay, so A minus B is equal to 0, so it prints at 0. A minus B is not equal to 0, so it prints out 9999. And there should be a new line character here. Okay, so it works. But this kind of a bit cheaty. Like, you could do this in Vesp if you just move the stuff to your move all of your value into the frame buffer and display it the other way. But that would take too long, so I just did the display part using C++. And that's about how Homework 5 works. Like, there's a lot of stuff going on. I don't know if this is actually helpful or not, but thanks for watching.